crisis averted. Yes, the crisis has been averted, HNAU. The crisis actually has not been averted, unfortunately. The reason that the stream is starting late today is because, well, we're having a little bit of a problem. I wanted to get rid of my taskbar. I was talking about this on the last stream, and I thought I had seen some people say that you could finally get rid of the taskbar again. You used to be able to get rid of the taskbar on Windows XP, and of course when they introduced their improvements to Windows with Vista and 7, where they improved everything, they improved it so that it no longer works. So you can't actually hide the taskbar anymore. Basically, you only have this thing that basically it always pops up if you go back up to the edge of the screen, and it's awful. And so you used to be able, there was a thing in here that said taskbar is always on top or whatever, and you could uncheck that, and that was awesome. It was like totally perfect and did exactly what you want, because then all of your full screen windows would just be over it, which is what I wanted. But I don't know what to say. So basically, I was trying to get rid of that. I was looking on the web for some of these things, basically, and yeah, couldn't find it. There's like some tools. Of course, they got rid of it so thoroughly that you have to taskbar always on top, Windows 7. And like I was trying to find people who were talking about this sort of thing, and there's like utilities you can install, where I tried installing one of them, but it didn't actually work. So basically, like, you know, when you're not using the trackbar start menu, blah, 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 right, it simulates to keep taskbar on top, unchecking that box. This is what I actually wanted. So like, I've been surpassed. The 7+ taskbar tweaker does this job better than my code, and I recommend you install instead. I installed this. I do not actually see any option for doing it, so I don't know if I'm just using the tool wrong. I haven't tried this one yet. I guess I could try it just to get a few more viruses on my machine, you know. It's always good. But I don't actually know, yeah, if it would actually work. I could try it, and I just don't understand why this guy thinks that this tool does it, but he doesn't actually say how you would do it. You can see here, like, I've got this thing installed. If you open it up, right, I don't even see an option for it. I don't even see a heading where the option would go. But I don't know, like, there just doesn't seem to be. I got nothing. There doesn't seem to be any actual thing here to click on. You know what I'm saying? You know what I'm saying. Does anyone know? No one on the stream probably knows, because I'm guessing that people on the stream probably have already moved to some other thing. I should probably try to install Classic Shell and see if that has it, or one of those other shell tools, and see if it, you know, can replace this whole taskbar with something more usable. But yeah, so he says install 7+ taskbar tweaker. Here is 7+ taskbar tweaker. I do not actually see any options that actually would work. Dropping, hovering, thumbnails, pinned, left click, other, hide the start button. That actually does hide the start button, but that doesn't help. Show desktop button can go away. That doesn't help either, although I'd be fine with having that go. I never use that button. Display seconds is good, but doesn't help here. Reserve empty space doesn't help, doesn't do anything. In our case, I don't know. I guess I could look at the help. Maybe the help has something. Let's see. Search. Top. Some of these send options let you tune aspects of the tweaker. Disable topmost. Oh! Wait, so it does have a setting. But how do you access the setting? Options EX. You can use the advanced objectives. It can be opened from the tray icon. Okay, alright. Let me see if I right click on the tray icon. Advanced. Okay. Wait for it, people. This could be exciting. This could be exciting right here. Apply. Okay. I don't think I also accidentally shut this thing off. So let's see. Run at startup. Okay. All right. Done. There we go. Let's take a look. That does not appear to be disabling topmost to me, but maybe it did. I don't know. It doesn't look like it. Let's take a look. By default, taskbar is on top. This option allows you to change behavior. Always on top, not always on top, but not over. Okay, so I got to set it to 2. RTFM, I guess, is the answer there. Let's try it. 1 minute left in the stream. Can we do it? Can we do it? 2. Return. Apply. Okay. Oh my God! Look at it. Are you looking at it? Look at how beautiful that is. That is so excellent. Although it ruins other topmost windows? Like my topmost windows are now not topmost anymore. Oh. Oh. So close and yet so far. Why would you taunt me like that, people? Why? Well, I guess we could also just double check trying, I could exit the timer app and then start the timer app again, I suppose. Let's see if that helps. There we go. So I guess it did it to all top level windows. It must have messed up the Z order. All right, so what day are we on? I don't even know. What is it, day 37, I want to say? Let's take a look. What day, what actual day are we at right now? Sorry, we may have actually solved this problem, so I'm pretty happy about that. But let's see make sure we're on the right day here. Video archive, day 37 was yesterday, so we're on day 38 today. All right. Well, that's pretty exciting. You have to admit that is pretty exciting. I am relatively excited about that. Let's get all this stuff straightened out again. That means we no longer have this ridiculous unused area at the top of the screen. We can actually have everything go up to the height that it was supposed to be. Let's see, does our Emacs go to the whole? Look at that! That's fantastic. Well, that is just great news. I'm very happy about that. That is super cool. You know, it's the little things. You know what I'm saying? Even if someone else had to write them for Microsoft, at least someone did. There we go. All right. I guess we can start the stream now. I hope everyone shared in that triumph. I don't know if they did or not. Can't see what's going on there. Yeah. Yeah. I think everyone's pretty excited. I know I am. So let's go ahead and get the gloves on here, and we will go ahead and start the stream now that we've had that small victory. I guess I can close the old command prompt from yesterday as well. Get back to our standard screen, and we can actually get programming, which seems like a pretty good idea since this is supposed to be Handmade Hero, not Handmade fighting with the Windows user interface to get the taskbar out of the way. Even though sometimes that is what programming ends up being. Fighting with Microsoft to get it out of your way is often a thing that does happen when you're programming, so, you know, it's not that far off, I suppose. But let us go ahead and return to the program. Hello, everyone. Welcome to day 38 of Handmade Hero, the show where we code a complete game from scratch using nothing but our typing little fingers, no libraries, no engines, so we can actually see the complete process of making a game, and you can learn how absolutely everything works, right from where the pixels are drawn on the screen all the way up to how the game code operates at a high level. So today we happen to be at the point where we are putting sprites on the screen, and we are not doing our full renderer yet because that's a little bit more of an involved process, but basically we just wanted to have something where we could easily put some graphics up on the screen for our own testing purposes as we are sort of going through and figuring out what we want in our engine architecture. And one of the big parts of that, obviously, is going to be what we want for our rendering architecture, and it's kind of hard to make those decisions without something to work with. So that's what we wrote yesterday, but we have a couple things left that we need to do to it, so that's what we're going to be doing today. If you'd like to follow along at home and you went to handmadehero.org and pre-ordered the source code, you should have gotten a link in your email address, in your email inbox. And that link will allow you to download both the art assets that we're using, and it will also allow you to download the source code. So if you download that source code, today is day 38, so go ahead and unzip day 37 source code out of the source code zip file. So zip file basically has a ton of little zip files in it. It's like a Russian nesting doll kind of a thing. And there you go. That will basically give you the same source code that I am starting with right now. So let's go ahead. We've got a bunch of stuff to do, so let's get to it. I'm going to open up the debugger here and just point out where we were before. If you remember, we were looking at putting the sprite up on the screen, but the colors were wrong. And so the question was what was going on there. And it turned out that since I think it was my fault, actually, I had run a little resizing tool on some of the, I had run ImageMagick to resize some of the bitmaps, and it wrote them out in a different byte order than the ones that came straight out of GIMP. And so basically what we have to do today, we figured out this at the end of last stream, that basically the bitmap header has these things at the bottom, red, green, and blue maps that we figured out, and we've got them laid out in here so we know where they are in the file as well, that basically tell us where the red, green, and blue components go. And it's, I guess, assumed that the alpha is just whatever these aren't, because there's obviously an alpha component as well, and there isn't an alpha mask parameter as far as I can tell, although maybe there actually is in an extended version of the file format, I'm not sure. But when we were looking on the website of the documentation, it looked like it was only red, green, and blue. But that doesn't really matter because we can tell what the alpha is because it's where the red, green, and blue isn't. So what we need to do here is we need to, I don't know if you remember this, but basically we already were doing a thing where we were swapping around the order of the stuff that came in because it wasn't the order that we wanted. So our pixels were packed with ABGR, which is this thing right here. And so this is actually not correct anymore. This comment we've learned is erroneous. And so basically what we need to do is change this to say what's actually going on, which is the byte order in memory is determined by the header itself. So we have to read out the masks and convert our pixels ourselves, right? And so that's what we're going to have to do today. So basically now we assume that when we load one of these BMP files, we have no idea what order the things are in, and we basically have to go ahead and figure out where they are. Now we could, we know that basically none of the files that we're saving are going to have anything other than 8 bits per channel. So we do know that we're basically looking at an OXFS kind of a map, but we just don't know where it actually is in the 32 bits. We don't really know where it shows up. So what we need to do is we basically need to get a shift value for each of our components. So if you think about it, we basically have a redshift, not to be confused with the kind of redshift that they use in astronomy. Obviously that's a different kind of redshift. But we have a red shift, a green shift, a blue shift, and an alpha shift, right? There we go. And so what we're going to have to do is we're going to have to figure out what those are, and then we're going to have to come in here and actually get them out, right? And so when we actually build our thing, we could make this a little simple by taking the actual color value, grab that, and then we could do it this way, just make it a little more easy for us to write here. We basically can figure that we know we need to pack things such that the alpha is on top, then the red, then the green, then the blue, right? So what we need to do essentially is we need to shift the red. Well, you know what? Unfortunately, I don't know that there's really any way we can do the shift totally generically with only one shift. I'd have to think about that because really we need to shift it. It could have to shift in either direction, right? Where the red is in our source, I don't know if you guys are already on the same page here in terms of what I want to do, but basically I've got something where I've got a 32-bit value, right? This is my 32-bit value, and essentially I've got the 8s here. This is 8 bits, 8 bits, 8 bits, 8 bits, right? This is the low, this is the high. And basically what I need to do is I've got, some set of things. I've got the red is somewhere, the green is somewhere, the blue is somewhere, whatever. So I've got my A, B, C, D, and I basically need to rearrange these, right, in some arbitrary way. Like I have no idea where they actually need to go, but I know that I'm going to determine where they need to go. So what I need to be able to do is I need to be able to mask it out and then shift it to the right location, but I don't actually know which direction it's going to have to go. It may be that like this was the green before and the green now has to go here. So the shift would actually be a left shift, right? It'd be getting higher. But it could be the other way around where it's actually below and so it's actually going to be a right shift, right? And since I don't actually know if there's really any way to write that concisely, what I think I'm going to have to do instead is first shift it down and then shift it up. So I know that my shifts are always are always going to be to the right for the parametric amount. So basically I'm going to take the C and I'll shift it down by the alpha shift value, right? Whatever that alpha shift value is. I will AND it with the mask so that I know that I've basically now just got the alpha sitting in the low 8 bits, and then I'll shift it up by 24 to put it in the position where I actually want my alpha to be, right? So that is basically what I'm going to do for each of my values, just so I can, usually, a lot of times people call this like a swivel. I'm not really sure why they call it a swivel, but a lot of times they do. So I basically want to get the red, the green, and the blue by shifting them down like this, masking them, and then putting them back into the place where I actually want them to be, like that. And so really all I need to do here is figure out what the shift would be to get whatever the value is down into the bottom, down into the bottom 8 bits. Problem is I don't actually have that. I have the mask. And I don't have an alpha mask technically, right? Ooh, hello. That was odd. What I actually have, I've got the red mask, right? That comes out of the header, red mask. I've got the green mask. I've got the blue mask. But the alpha mask actually isn't there, as far as we know, right? I don't actually have an alpha mask. So what I'm going to do is I'm going to assume that the alpha mask is just wherever there wasn't a red, a green, or a blue. So if I OR the other masks together, basically make a composite mask that would mask for red, green, and blue all at the same time, I'm going to assume that the not of that, if I flip all the bits in that, then I'm going to get basically where the alpha is, right? Because that'll basically give us wherever the other ones aren't, right? And I'll dummy up these values for a moment just so I can show you what I'm talking about for those of you who may not be super comfortable with bit operations yet. I think it's amusing actually, but I think someone was actually asking just on like a stream like yesterday or the day before whether we, if bit operations normally get used, and today is like all about bit operations, right? So the answer is definitely yes. Anyway, so if we read out the red, green, the blue mask, you can see them here, right? There's the red mask, the green mask, and the blue mask. That's saying it's basically the red's in the high, green's in the second down, the blue's in the second from the bottom, and the alpha, we don't know. We don't get that, right? So what I'm going to do is I'm going to OR them all together, which will basically produce OX, FF, 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 right? And then I'm going to knot it. So you can see that basically what I get is I get what the part is that isn't filled in any of these other ones, right? And so that's what I wanted. I just wanted to fill in that extra value, right? And I can do that a little more explicitly if you guys want, just to see what I'm talking about here, right? I can do it in 2 steps. I wish they allowed you to step into an expression. It'd be so much nicer. God, all the things debuggers could do and don't. So there's the alpha mask first before I've knotted it, right? You can see basically if I OR them together, I get the composite of all of those masks basically, and then the knot just flips. Just flips what the actual values are, right? So that's what I was doing there. So that gives you all the masks, but now we have a problem, which is basically we need to actually know essentially what the lowest bit is that's set in these values, right? Because we need to know how far down to shift, so we essentially want to count how many bits there are that are 0, starting from the first bit and going up to the very first bit that's set, right? Now, what's interesting about this is actually something the processor can sometimes actually just do for you. It's called a bit scan, right? And basically, like, well, you know what? I can even probably search for it here, right? So if I look in here and say bit scan forward, there we go. If I take a look at this here, you can look at MSDN. It's actually compiler intrinsic. The compiler can actually emit instructions for it. Basically what it says is it'll search from the least significant bit, right? Which, if you remember, if I was least significant at the bottom, right? So this is, we're talking about the bit here. This is the most significant. This is the least significant bit. And this is the most significant one, right? And this in our 32-bit value. So this is bit 31, and this is bit 0. Okay, so basically if we do bit scan forward, what we can do there is we can say, okay, what I'd like you to do is give me back whatever the position was where the first bit was set, right? So tell me which bit was the first one set, which is kind of what we want because up here somewhere we've got 8 bits set, right? Somewhere. And we want to know how far to shift them down so that they line up right here, so that they start here. And so really what we're trying to do is we're trying to do a bit scan to find where that value is, right? So we could implement this ourselves, obviously, right? We could go ahead and actually search for it. So I could do, for example, I could come in here and say internal, and I could basically have, I guess, a bool 32, for example. If I guess I don't really know, because the way that this processor, I don't actually remember how the actual instruction works. But it looks like the way this thing works is it basically returns a Boolean that says whether or not it found a bit at all, and then it writes to an index to tell you where that index, where it did actually find it. So if we were going to mirror the way that worked, basically, it's an unsigned char that it returns, and so I don't actually know that I care about that so much. So I'm going to do a uint32 there, and then it's going to be an unsigned int that's the index as well. So basically, it looks something like this. Bit scan forward, right? And if I go ahead in here and say, all right, I want to implement this myself, right? You can kind of see how we would do it. It's not particularly complicated, right? We just have a uint32. Well, I can actually do a bool 32 here because it's still a 32-bit value, and I can, found equals false. I can then do a search, like literally with a for loop, right? Which is, test equals 0, test is less than 32, plus test, right? And then I can do value and 1 shifted up by whatever the test amount is. And if that turns out to be set, right? If value and 1 shifted up test turns out to be set, then I will write the value of the bit into the result, and otherwise I will not. And so that will basically give me, whichever one it hits. Now, if I find one, I've actually done that slightly backwards. If we're trying to look for the first bit that's set, not the first bit that's not set. So we actually, as soon as we find one that is set, we want to stop looking. And if we didn't hit one, we will write to our index value, right? So if it's a 0, we count that as an index. Okay, never mind. No, I'm correct. I was correct the first time. Sorry, I confused my own self there. As soon as we find those set, we're actually trying to return that index. So we just set the index equal to the one we found, and we break out. Everything should be fine, right? And I guess we set found equal to true here, so that we know that we actually found one and we can return the value properly. Now let me take a look here, because since I confused my own self during the explanation, let's actually go ahead and make sure that we actually did it correctly. So this is redshift. We pass the address of redshift, and we will basically look and see red found equals that, and we can assert red found like so. And then we'll compile that. Oh, right, we already have the redshift. There we go, like so. And what was the problem? Cannot convert argument 1 from int32. Oh, yes, right. Sorry, uint32. There we go. So if I go ahead in here and actually step into it, what I should find is that I pass in here. I've got a value that I'm checking for. It's all the way at the top. So I'm expecting the value to basically be 24, right? So I come in here, and I keep shifting up test to see whether it actually hits against the value. It's not going to hit for the first 24 times, right? Blah, 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 blah. Well, 23 times, I should say. Turn off hexadecimals, you can see 13, testing, 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 up to 20, 22, 23, and now 24 should hit. It writes back to the index, so now the index gets 24 written to it. At least that's what should happen. Find out. Oops. Start index, right? 24. We say that we did find it, and then we return. So there we go. We've done the bit scan forward, and we say that red was found. The red shift is 24, which is exactly what we wanted. So that's the bit scan operation, but we're now doing it in a very slow way. So what we'd like to do is we'd like to actually have the processor do it. And this is the perfect time to talk a little about the intrinsic things that I keep alluding to but haven't actually done yet. So maybe today we will actually do intrinsic so that we can call the bit scan forward. Okay. Yeah. Also, I should point out, for those of you who aren't familiar with these, there's a bunch of these sorts of things, right? So you can actually count the other way as well, right? If you want to do from the high downward to count like basically the zeros that come at the top, you can call the reverse version. So you know you've got there's a bunch of intrinsics that will output those sort of things that the CPU can do, but that don't really have any way of specifying them in C per se. So anyway, let's go ahead and get this working first with that. But then what I think we might do is just go ahead and do that today, so we can go ahead and move this into the intrinsics and call the MSVC version. And there we go. And we can leave this, you know, sort of slow implementation as the reference implementation as well, which would be nice because that would basically mean that, you know, we wouldn't have we wouldn't have a problem if people wanted to compile on an architecture where the CPU can't do that and they just need a slow version of it to make it work. That's good too, because remember, this isn't really time critical here. So at least for this function, it wouldn't matter if you could use the slowest possible thing and it wouldn't really matter, right? So the other thing too is I wonder if I should fix the API a little bit, because I guess we can always wrap the intrinsic in our own inline. That just kind of would get you know, kind of spelled out a little bit. I could make it so you don't have to pass an address there, basically. So I could do something more like this, which is like a bit scan result or something like that, which is you know, whether or not it was found, and the uint32 that was the index, right? Something like this, and then that could do something that looks more like that, inline bit scan result. So bit scan result, and that would equal you know, nothing at first. Having some typing problems today, it is true. And so then when we actually go through, we will then return the result here, and we will do results.index equals test, and results.found equals true, like that, and break out, and then we'll return the result that way. And so that would be a little handier than having to do sort of passing the address nonsense, which doesn't seem particularly useful to me. I don't really think there's any reason to structure it like that. I was just mirroring the way they were doing it in the other one. So now you could basically do something like this, where we basically have these. So we'll just get the bit scan results out of our mask values directly, like that. And we'll do the bit scan forwards here. And you know, the other thing I might do, since I'm kind of in charge now and not Microsoft, bit scan forward's kind of a weird term. Maybe I would do something like find least significant 1 bit, or least significant set bit, something like that, right? Because that actually says what it is. Like bit scan forward, well, what do you mean by forward? At least now we know we're trying to find the least significant one that's set. And so that actually seems maybe a little more sane to me. I don't know. I guess it would depend on endianness things and blah, blah, blah. But I think that might be a little bit better because at least I understand what that is when I read it. At least on one architecture it makes sense. So that seems like perhaps a better idea. So let's go ahead and do that. We'll now get each of them out, blue mask and alpha mask. So now we have found those, and now we just shift those by their indices. Like so, index, 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 and we can also do an assertion on each of them because basically we're not supporting loading anything that doesn't have all of these channels at the moment. Maybe in the future we would, but for now we want to at least ensure that we don't actually accidentally load something that doesn't have one of these channels. So let's take a look at where that puts us on the scale of fixing our color problems. Hey, it looks exactly right to me now. The only thing that we're not handling now is, of course, the alpha blending around those the edges and on the background, and that's the next thing that we have to do anyway. So that seems like a pretty good thing to do. I'm going to go ahead and say, though, that since we've got a fair bit of time here, I'm just going to go ahead and give the intrinsic thing a shot, just because it's about time that we started talking about those sorts of things. We don't have to do very much. It's not very complicated. It's a very simple thing to do, so it might be a good one to start with. So basically what I want to do in here is I want to move this bit scan result. I want to move this out, and I want to move it to here, right? And so what I want to do is be able to have this function such that if we are on a compiler that can do it really quickly, it will do it, and not have to go through this for loop. It'll instead just tell the processor to basically tell the processor to do it, in a much more expedient way, if that makes sense. So really what I need to do here is I need to be able to figure out whether or not, basically whether I'm on what compiler I'm on, if that makes sense. And as you know, as I said, I talked about quite a bit at the beginning, you want to keep all of your stuff segregated as much as possible in terms of keeping platform code out of platform-independent code, right? So you'll notice that we buried everything inside Win32 handmade, and you'll notice none of this stuff leaks out into our main code. All the Win32 specific code is all in here, right? But there are limits to what we can do there if we don't want to sacrifice performance. Like what I could do here, right, is I could call a function back in the platform layer that did this operation, right? And that would keep it, and I could even pass in a pointer to that function so it was completely isolated. I could do all kinds of stuff. But the problem is the only reason why you ever care about intrinsics in the first place is for performance. If we didn't care about performance, we'd just run this for loop, right? So the intrinsics file, the whole point of this intrinsics file is going to be, this is the place where we make a compromise and say that this is the place where we're allowed to do platform-specific stuff that can be directly included right into the code of platform non-specific stuff, if that makes sense. And again, the only reason we're doing that is for performance. If we didn't care about performance at all, if we literally just had no performance concerns, then there would be no reason to do this. There'd be no point. You would just always do things the way we had been doing them. But in the case of intrinsics, which you're only using really when you're caring about performance in the first place, this is where that sort of stuff comes in. And so what you want to do is you basically want to have it isolated again. Even though you're sort of saying it's okay to mix things up a little bit here, you still want it as isolated as possible. And so you want to basically boil it down to like a file or two that have compiler switches in them and that bring in that sort of non-independent parts of the code, right? So that's basically what we're going to do here. So what we're going to do is basically say, if the compiler is MSVC, right, then we know that we can issue this thing because this compiler happens to support this bit scan forward thing, right? And we want to do from LSB to MSB, so we're basically going to call this one. We know that in this case we're scanning a 32-bit value. So basically what we're going to do here is we're going to call this bit scan forward. The result found is going to be equal to that return value. We're going to pass the address of the index that we wanted to be set, and it'll set it, and then we're going to pass that value. And so that's just going to allow it to do it right there. We're going to make sure this is marked to inline, so hopefully if the compiler isn't dumb, it will go ahead and say, oh yes, we can go ahead and inline this directly and turn this into a instruction, right? So that's about all we have to do there, but we have to do this compiler determination, and so I'm going to go back to our handmade, I believe it's handmade platform, right? Yeah. In handmade platform, what I'm going to introduce at the top, kind of like, we have this sort of basic, this is like the basic setup for the code. This is what has to happen in the code. I'm going to do a little thing here which basically says, compiler MSVC is 0, and maybe compiler LLVM, because I know those are the two things at least that we will compile under, right? And what we will do is we'll sort of do an if here on some kind of thing. Basically, if not compiler MSVC, I should do it this way. If and def compiler MSVC and if and def LLVM, like this. I could write these out a little bit more cleanly so you can kind of see what they're doing. So short, if and def is like a shorthand you could do defined like that. So what I'm going to do is, if the compiler variables, and maybe I'll even make a little section here like this, and this can be, note Casey types like this. Thank you, Emacs, for indenting me. It's finding the C++ bracket up there and doing the indentation, which I didn't actually want to do. What are you going to do? Compilers. So basically what I want to do here is I want to basically say, okay, if the build system, whoever is building us, our batch file, whatever, if they want to explicitly set what the compiler is, then we'll just let them set it. So basically we're only going to set these if they're not already set. So we're going to clear them to 0, or actually I guess what we could do is if they're not already set, right, then what we do is at the end here, no, I still need to do this. So we need to do something like if the compiler is not set at all, right? If we have no compiler set whatsoever, right, this sort of thing, then inside here is where I'm going to actually try to determine what the compiler actually is. So if neither of the compiler things have been set by anyone, then I'm going to go ahead and try to see what the compiler actually is. And MSVC, for example, will automatically define something that tells us what it is. I don't remember. It's like MSCver. I mean, I think it's something like that. But I want to actually go see what it actually is before I make that proclamation. Underscore MSCver. Yeah, underscore MSCver. So basically, I want to do that and say if that's true, then compiler MSVC equals 1, right? And then what we'll also do is we'll do an else here, and in this case we'll just assume it's LLVM for now, but we'll put a to-do here, which is basically like more compilers or something, right? Maybe even like that. And so eventually we'll do something a little smarter than that as we go. But right now we're only compiling on MSVC, so you know, for now that should be good enough. So when we actually do that, let's take a look at what happens here. Oh, right, we have to undefine compiler because we defined it to 0, and you can't just change it, unfortunately. You got to undef it first, like so. And then I got one missing endif, so then there's an endif there. All right, so now it's claiming that bit scan forward is not defined, and that may be true. Let's see what has to be defined in order for that to exist somewhere. Let's see. Well, it looks like we just need to do that, or do we actually have to pound include in trin.h? I'm not actually sure if we need to do that or not. We could take a look. I guess the first thing we could do is try this first and see what it does. So if we're defining MSVC, we can basically now have our little section where we do the things that we want to do if MSVC is here, such as that pragma. Intrinsic function not declared, so okay, so I guess we have to include this file as well, which is the intrinsics, and then we'll see. Okay, bit scan forward cannot convert argument 1 from uint32 star to unsigned long star. Why not? Types pointed to are unrelated. Is that really true? Why would those be unrelated? I guess unsigned in and unsigned long are technically different types. Oh, the mysteries of C++. I've been programming it for so long, and yet things like that always still confuse me. I'm like, what actually do you believe the technical difference to be between those types? And I have absolutely no idea. Oops, put that in the wrong place. There we go. So I believe that should probably work. Let's find out and see if it does. And hey, guess what? It does. And now let's take a look in there and see what it actually did differently now when we step into it. So if we step in here, you can see that this is actually using this line that we talked about. And if we go to the disassembly, we can take a look at what it does. So essentially what happens here is, do you see this BSF? That's bit scan forward. It's literally one assembly language instruction that does all the work of that for loop. Now don't let that fool you, because assembly language instructions can still take a while to execute sometimes. But the point here is basically that that is so much more concise, certainly, to the processor, and it's probably going to be much faster than if we were to actually have to code the loop ourselves, because if this is executing something in microcode, that's still going to be a lot faster, right? So basically what happens here, in fact, you can even watch it work. What it's going to do here is going to move the value, this thing right here. It's going to load that value into the EAX register, right? And that's this register right here. It's a little confusing because we're in x64 mode, which means that it uses RAX to denote the AX register because it's 64 bits long. But really what we're talking about is we're talking about the bottom portion of it here, right? We're talking about the bottom 32-bit value. So when we do that, you see how it loaded it in there? There it is. It just loaded it right there. And now it's going to call that BSF function on the value in the register to load it out, right? It goes ahead and does that, and the destination is also EAX, so it's going to write the result back in there, right? And you can see that it wrote the result back in there, and that's the result that we were expecting, right? That's what we wanted it to actually have. Again, it's in hexadecimal, which is why it looks like an 18 instead of a 24. But you know, that's just well, you know, I can here you go. So OX18, right? You can see that that's just the hexadecimal encoding for 24. So there it is. And then that is the entirety, that right there did like the entirety of this loop, right? So that's intrinsics in a nutshell. They're really pretty simple, and basically what we want to do is we want to do those for anything where there is a convenient CPU instruction so that we can access it, because we don't want to go around, especially when we start getting more time-critical code, we don't want to go around wasting a lot of that stuff that the processor could do for us by obfuscating it. Now, it's possible that the compiler might have actually been smart enough sometimes, depending on the compiler, to actually realize that this is a bit scan forward, but why make it do that when we could just go ahead and say this is exactly what we want, right? And so now we've done that. And we're in good shape. So now we're loading our stuff, and we're pretty happy. But if you actually take a look at what happens here, you'll notice that we would like to be able to composite this guy on top of things, and right now we're not actually doing that. And so that brings up use of the alpha channel, which we should talk about now. It's actually very, very easy for us to make this work. Well, you know what I'll do first? I'll basically show you the really simple version first, and then we'll talk about it a little bit. So as you know, the alpha channel, right, if you remember how this works, in the actual art tool, let me see if I can actually, how would I do this? I'll go to handmade data test, and I will load up that hero front head. There we go, edit with GIMP. So if we look at this here, you can see that basically you've got your red, green, and blue color channels, but you also have a fourth channel, and that channel is called the alpha channel. Now, most people probably sort of, even if you don't know exactly what that is, you know intuitively now what it is because you've probably seen it in paint programs. Like, you've probably worked with it before, right? And so if we take a look at the channels dialog, let's take a look here inside GIMP. There's a channels dialog, right, which is this. You can actually see, I can turn off the channels, and we can actually see the alpha channel by itself, right, instead of the other channels, which is basically all the alpha channel is it's basically just something that says where the image exists and where it doesn't. And it's got partial values around the edges that basically say, well, it was transitioning at this point, right? It was transitioning. It's anti-aliasing that edge, basically, right? It's giving a partial value because the shape obviously can't be it is not perfectly pixelated. The shape was actually supposed to be a smooth line that went through there. And so these alpha values are basically there to kind of smooth that out and to sort of give you that gradual fall off so it's not a hard cookie cutter edge, right? It just kind of feathers the things into the background for you. That's the way the art was set up to work. So right now we're drawing those red, green, and blue channels, but we're not doing anything with the alpha channel. And obviously, since the alpha channel is the only thing that tells us where the image exists, we need to start doing something with the alpha channel to display the person such that display things on top of other things so that like bottom layers show through upper layers, right? And so inside our renderer, this is going to work. Well, yeah, I won't say how it's going to work in the renderer necessarily. That's a little premature. So let's not say that word. Let's say a different word. What I'm actually going to say is not that. What I'm going to say is let's talk about one way we could easily implement this for our testing purposes. For our testing purposes, what we can do is basically do exactly what Photoshop or anything else does, where we basically just think about things in terms of layers. We could draw something first. We could draw down, our trees or whatever in the background, right? And then we want to stick a guy on top of that. What we would do is we'd essentially think of creating a separate layer, right, which has our guy on it. And basically what we'll do is when we draw that layer, we'll only draw in the places where the alpha channel says there was actually a shape, and we won't touch what's underneath in the places where it's not. So we'll basically do compositing very much the way you would think about it in Photoshop, where you have one layer and you're basically drawing layers on top of each other, and you just don't draw where the alpha channel says there isn't anything, and that gives you the show-through. So it's basically like taking pieces of paper, cutouts, and stacking them on top of each other. Wherever it was cut out, you can still see through to the thing that was underneath, right? So that alpha layer, the alpha channel, is basically telling us where to do the cutout. It's basically what tells us how to do the cutout. So how do we actually implement that, right? Well, while we are drawing, right, we basically have something, we've got our trees, they're there, and then we've got our guy, and he's got the alpha channel on and it says where things exist. And basically, it's 0 everywhere where he does not exist. It's 255 everywhere that he does. and at the edges, it's somewhere between those two values, right? So it's basically a brightness value, you might think of it, between 0 and 255 that says how much he exists at that particular point. So what we would like to do, right, is we'd like to think about that essentially, for now, as an opacity value, basically, to say how much of the guy blends through. And by the way, we could use this alpha channel as well for partial transparency. Like if we have something that's supposed to be sort of ghost-like that we want to sort of only partially blend on, just like in Photoshop, how you can paint the alpha channel to be some middle value, like 128 or something, that's partially translucent, we might want to do that too. So what we'd like to do is use this value essentially as a way of blending in between the two, right? So I don't want to talk about that yet, because let's just do the simplest possible thing. Let's do something that, just for starters, uses 0 or 255, or sort of rather on or off. So we'll basically say if it's 0, we won't draw anything. And if it's 255, if it's anything from 1 to 255, anything in between, we will. I guess another thing we could do is say 128 is the cutoff. So basically anything less than 128, we won't draw. Anything greater than 128, we will draw, right? You can pretty much see how we could do that very simply, right? Because we're iterating over all the pixels of the guy in our draw bitmap routine, right? We iterate over all the values here to do this def ++ equals source ++, right? So what we could do instead is we could go ahead and change the way this works. We could do both. We could always do both advances, right? And we could isolate just the copy like that. And what we could say is, if that source value, the source part that's coming in, extract the alpha, right? We shift it down by 24 to get just the alpha by itself. If that value is greater than 128, then we do the copy. Otherwise, we don't. Make sense? Right? So if we did that, and we ran it, we now get much more of what we would expect to get, right? We now get something which doesn't draw the guy everywhere where he had an alpha value less than 128, and it does draw the guy everywhere there's a value over 128. And all we did was just add that one simple test, right? That's all we were doing. Now what you'll notice is it has a very hard edge around him, right? If I was to do the zoom in on this, right, let's say we go into Krita there. I don't actually know how Krita works here. Can I do a paste as new image? Paste into new image? I don't know what you're asking me. I don't know. I don't really know how to use this program. Oh, is this what I want? I don't even know. All right, yeah, I guess it is. It's doing what I wanted. Okay, good enough. So if you look in here, you can see, there's a lot of anti-aliasing. This is very smooth graphics. There's a lot of anti-aliasing everywhere in here. There's a lot of kind of, blurring of those edges to make them a little smoother. That's kind of the way the art works. But when we get to this guy, you'll notice there's no blending there at all. So it's a very hard pixel edge along the guy. And the reason for that, again, is because we're not using any partial alpha values at all, right? We're not doing anything to try and use those values that are in between 0 and 255. We're just making a hard cutoff. Now, what this is often called, in fact, you'd see this in 3D graphics a lot, it's called alpha test, is what this is called, which is basically a hard clamp limit, which basically just looks at the alpha value and says, I'm either going to do an operation or not based on whether the alpha exceeds a threshold or not. And that is exactly what we implemented. This is basically alpha test right here. But what we'd like to do is something a little bit better than alpha test. We'd rather do something that's actually some kind of an alpha blend, a blend that uses the alpha value to compute the resulting color that will use what's underneath to actually and show through what's underneath in case the alpha value is not 255, if that makes sense. Now, we are going to do this in the slowest and dumbest possible way because I'd like to show the math being explicit. And so this will not be fast by any stretch of the imagination. It will be very slow. But again, we are not writing the render at the moment. What we're trying to do is write stuff that we can use. And so what I'd rather do is just, well, you know what? No, I'm not going to talk about how to do any of the fast stuff. We're just going to do it in the slowest possible way. So what we'd like to do now is we'd like to go ahead and see about how to actually do that alpha blend. Now, I probably shouldn't spend too much time belaboring this because there's actually an entire video, in fact, of me explaining interpolation. And I don't know whether we want to rehash that entirely on the stream or just, did that just crash? I think Krita just totally crashed on me. It did, didn't it? Ugh. Yes, it did. Krita just totally just crashed. It just full on went away completely. Ugh. Ugh. Well, what are you going to do? Let's launch it back up. Come on. You can do it. It was working so well there for a while. See, I tried to make a new image. I guess the thing to remember is never try to make a new image, people. That's the rules. You don't ever want to make a new image. All right, that's fine. Make the image, please. There we go. Hello? All right. Okay. So here we go. So what we need to essentially do here, right, is I want to make something that allows us to smoothly blend between the two values. So we have a background value, right? I don't know why that's always the hand shape. It just is. I guess the hand was what they thought was good there. So I have a background color that's coming in, right? I've got a hand, apparently, that's drawing this now. I've got a background color. It's funny to have it be a hand like that. Does that help at all? Nope, that doesn't help at all. Welcome to the mysteries of the universe, ladies and gentlemen. I've got a background pixel, so this is one pixel, right? I've got a background pixel, and I've got a foreground pixel, right? That this is the, I guess I'll call this the sprite pixel, the bitmap pixel that we're drawing, right? So this is whatever's in the buffer, and this is whatever's in the thing we're putting on top, right? And so in this code here, we've got a source and a dest, right? So basically, this is the dest. This is the thing we're writing to. And we've got the source here. This is the source. This is the thing that we're trying to draw down. This is the guy's head, right? So this is the trees, pixels. This is the head pixels, right? So now, if we do this, what we need to do is this is some color. You know, let's call that color A. And this is another color. We'll call that color B. Wow. This is awful. Like, I can't even click down anymore. Ugh. I tell you. Computers these days, nothing ever works anymore. Okay, so I've got these two colors, A and B, and what I want to do is I want to produce a third color out of these, right? I want to produce a C that's some blend between A and B. And what I want it to do is I want it to blend based on that alpha channel, right? I want the alpha channel to blend it such that when it's 0, I get A, and when it's 255, right, I get B. Does that make sense? So when I actually go to do this, what I need to do is figure out some mathematical way of getting from A to B smoothly based on another value, right? I need to figure out some way to pick, because if you think about the number line, right, you know, I've got 255 at the high end for each channel, and I've got 0 at the low end, right? Essentially what I'm doing here is I'm saying I've got 2 points on this, and I don't really know where they are. In fact, they don't even have to be in any particular order. A could be higher than B or vice versa or whatever, right? So this is, let's say, and this is, when I say colors, obviously I mean one channel. So we could think of this as just the red channel, right? Or the green channel or the blue channel, just one of them. So when I'm going to do this, I basically have whatever was in the background, whatever that channel's color was, right? That's here. And then I have whatever the new color is that I'm blending on top, whatever that the sprite is, whatever's in the guy, and that's here. And what I need to do is figure out a way to produce all of these values in between here, right? I need to be able to produce all of those values based on what the alpha channel is, based on what that alpha channel says. And if the alpha channel is 0, then I'm going to leave it where it was, so I'm not going to touch the background at all. And if the alpha channel is 55, I'm going to drive it all the way to B, right? So essentially the way you could think about this, and the way that I usually like to sort of explain it to begin with, is that you can think of it as being based around one of the numbers. We can think of it as being based around the number that's 0 primal. So the number where we have 0 yields that value, which in this case is the background color, right? We can think of starting there. And what we want to do is we want to start there, and we want to sort of go some distance towards B, where that distance is going to be 255 if we went all the way, right? And 0 if we didn't. So how do we produce what that actual distance is, right? What's that value? Well, if you know rudimentary math, you already know what that is. it's just b minus a, right? B minus a is, if you will, almost, and we haven't talked about vectors yet, but it is essentially a one-dimensional vector, but it's basically the delta, right? It's the difference between a and b, such that if I were to take a, start at a, and add back in some, this full portion, I would get b. And it's pretty trivial to see why algebra-wise, right? A plus b minus a, well, the a positive and the a negative cancel, and you just are left with b, which is the value that I said we would get, right? So this is basically the core of the thing that we're going to use to determine how to blend something, right? Because basically all I really need to do is take this expression, the a plus the b minus a, right, and say, as if I can figure out some way to only add part of this in there, right? All I really need to do is stick some kind of a percentage in here, right? Some kind of a value that's like a percentage from 0 to 100%, right? If I could just multiply this by some percentage, then I could go any percentage of the way from a to b just by changing what p is, right? A plus some percent of the distance from a to b is going to give me exactly what I want, right? So, if we go ahead and build on that assumption, right, if I want to say I've got a plus some percentage here, right, and also by convention this is often called t. I'll just point that out to you. We can use that because you'll see it use this way fairly often. But some percentage of the distance from a to b, this would basically give me that value that I wanted. This would be that resulting color. This would be the color that I wanted out, right? So really all I have to do is figure out how to do this. Now what you'll also notice is I can rearrange this expression in a couple of different ways. If you know algebra, which I'm hoping everyone on the stream does because, well, honestly, I've never thought about how to teach algebra before, so I don't suspect I would give a very good explanation. But assuming you know algebra, then you also know that I can pretty trivially use the distributive property here to distribute t into this expression, and I would end up with these terms, right? A plus tb minus ta, right? And I can rearrange those terms any way I want to. So I could group them this way, right? I could group them here by just moving this term. This term here moves here, right? And this term stays where it is. This term slides there. If I do that rearrangement, what you can see here is these two front terms both have an a in it. So I can pull out the 1 minus t there times a plus tb, okay? And now you have what's usually the more canonical version of what's called a linear blend, right? This is usually called a linear blend. And what it is, in either form, doesn't matter which one you find more attractive, they're just different ways of computing the exact same thing, right? Algebra, it's the same thing. All they are a way of taking one thing in, that's your starting value, one thing in that's your ending value, and basically being able to produce anything in between them by plugging in this percentage value here. But we haven't actually talked about how to actually make this percentage value work in practice. I just kind of magically waved my hand and said we had a percentage value here. So we now need to talk a little bit about just how that guy works, right? Well, literally in the math sense, and if you're doing this entirely in floating point math, it could literally just be a percentage, right? You know how to translate percentages. Again, if you've had high school math or whatever, you know how to translate percentages into floating point math. 100%, right, is 1.0. 50% is 0.5, right? 0% is 0, right? So the numbers between 0 and 1, all inclusive in there, are just those percentages. So really, in this expression, if t were to range between 0 and 1, including all the fractional values in between it, then no matter what a and b are, I don't care what they are, they could be colors, they could be anything, positions in space, whatever, doesn't matter, this will give us a blend between them, right? This will allow us to move smoothly between the two of them. Okay. And so if you're interested in more about this sort of stuff as well, I would also recommend, if you do want to go to YouTube on the handmade, in fact, YouTube Casey Muratori, I think is what you would type in here. Let's see here, Casey Muratori on YouTube, there we go. You can actually see in my videos page, there is a Witness Wednesday Part 10 interpolation video. And that is a full-on 50-minute explanation of interpolation and how it works in a lot of different ways. So basically, if you want to watch that for more information, you can do that as well. So where are we at here? We've only got 7 minutes left. So let's go ahead and slam in the floating point version of this so that we can actually see it in action, and then maybe we'll go ahead and fix it to be a fixed point version later. But basically, you can see exactly what I'm talking about here, right? So if I was to go in here and write the floating point version of this, let's go ahead and see what we get, right? What I would get, first of all, is I got to extract my red, right? And so my red channel is going to basically be shifted down by 16, whatever's in that source, right? And then masked off, so there we go, and converted to a float. So that's a number between 0 and 255. There we go. So then we have green. I guess I could just do R, G, and B for short, right? The green is the 8, and that's 0. Then the alpha channel, right? I just said I need it to be a number between 0 and 1. Well, this will be a number between 0 and 255, right? So if I want to turn a number between 0 and 255 into a number between 0 and 1, I need to divide by that range, right? I need to divide by 255. So that way 0 will map to 0, 255 will map to 1, and everything in between will map somewhere in between, right? So now I've got an AR, a G, and a B that are actually in floating point. Now I need to do the exact equation I just said. I need to create my new red, so I'll say that my red is now going to be equal to, oh, I forgot something. I need the desc as well. So I have my source R's and my desc R's, right? I've got to pull them out of here so that I can blend with them, right? So I pull out the desc R, the desc G, the desc B, and I've got my source R and source G. And to be fair, I guess I don't actually even care what these are. We don't even care if these are R, G, and B. We just care that they're channels 0, 1, and 2, right? We don't even care. So we could be wrong about these shifts and it wouldn't matter as long as we do them all. So anyway, now I'm going to actually produce my result red, and my result red is just going to be the exact equation that I just specified. It's going to be A plus T, A minus B if I wanted to do it that way, or I can do it this way over here, which is 1 minus T plus TB, right? So I can do it this way, right? Times A plus T times B. So we'll leave it that way for now, and we'll basically just say, okay, if I do what's my T? Well, my T is the alpha value. That's the thing that's actually causing it to work there. And then what's my A and my B? My A is going to be my destination red times my source red, because I'm trying to get to the source red, right? So that source red is the B color, and the background color is the A color, right? All right. I believe that's what we said it was, and so off we go. Now we'll go ahead in and just do that for all of them. Got to move that up a bit so it's not obscured by the 5-minute warning, the dreaded 5-minute warning. B, oops, A, G, B, G, B, like that. And then once we're done, we have to then reassemble the resulting value back into something that we can actually use. So what I have to do now is actually do sort of that build back again for the thing that we're going to actually write to desc. So we have to actually write something to desc. And what we're going to write to desc is going to be our R ORed with our G ORed with our B, but we have to now turn them back into actual rounded values, right? So we have to actually round the values each time now, like so, like that. I suppose we could just go ahead, since we know these are always positive, we could also do this as a truncation, which would be a little cleaner, right? I could do it this way, where we just actually truncate the values plus the rounding amount, like so, which I think, probably is a little saner here, since we are actually doing this per pixel. Per pixel things are very expensive, so we do have to watch out even in our test code so that we won't get too slow and not for us to use it. But we may replace this. We probably don't want to be doing this necessarily in floating point math the way that we're doing it here right now anyway. But anyway, point being. So here we go. We're going to actually take these values and pack them back into the places that they normally go, right? Like so. We basically unpack them and pack them. Oops. 8, 16, like that. The R gets shifted back up. I think I've put everything in there. I don't know. I wrote that in pretty quickly there. We'll have to step through this and see if it works. But I believe if we typed it correctly, we should have. I'm not going to paste things into Krita anymore. Lesson learned. We're going to paste things into GIMP from now on. That way if it crashes, we can still draw in the background. So now let's take a look at what happened. Can you see in here how that looks now? Where you've basically got you know, that kind of smooth, that nice smooth edge now that we're obeying the alpha channel. So that's a much nicer comp, right? That's just a much nicer thing to look at, right? And yeah, I mean, that's alpha blending in a nutshell, right? And so what kind of alpha blending actually is this? This is a straight linear blend between the two. There's other, like I said before on the previous stream, there's lots of different things you could mean when you say alpha blending. It depends on what that blend equation is, right? So basically, this guy here, this is our blend equation that we're using. There are other blend equations. So what I'll also say here is, to do Casey, someday we need to talk about pre-multiplied alpha, because we are not talking about that at the moment. But now is not the time to start that discussion. Suffice to say, this is not pre-multiplied alpha. But I'll just leave that for a little thing that we can talk about later on, because at the moment it's really not something that you need to think about whether it's pre-multiplied or not, but it is something that we will have to think about a little later on because it affects the math in very important ways, and we will need to switch to using pre-multiplied alpha for our final assets and so on. So, since we are basically out of time here, I believe, yes, we have 1 minute left. I'm going to call that done for the day. We have our alpha blending working. Oh, you know what? I'm not going to quite call it done for the day. I might do one more thing, although I think this actually will cause us to have a couple bugs. But I'm going to go ahead and make our hero head actually draw at the location of the player now. Yeah, so there we go. So there's our hero head. Very exciting. He's not actually in the right position, but at least he moves around there with the guy. Very much fun. Yay, yay for alpha blending. We're pretty close now, so I think basically tomorrow we'll have a little guy walking around instead of our rectangle because we're pretty close. All right, everyone. That is it for now. The Q&A has begun. Remember, I only start looking for Q colons when we start the Q&A. So please, if you have a question that you would like answered, now is the time to post it to the Twitch chat. Put a Q colon in front of it, and please keep the questions here in the post stream to stuff that's actually about the code that we wrote today or in previous days. If it's something that's off topic and about something else, please come before a stream sometime. Oftentimes I try to be on the stream about 15 minutes early to answer just any off-topic questions that you want answered. And so I do answer those if it's not on the post stream, because this is the one that kind of goes into the recorded Handmade Hero stream for people to learn on later, and I don't want to have lots of off-topic stuff that they have to skip through. Okay, tiny typo in function name, find least significant set bit is missing an I. Okay, thank you, Gas Blizzard. Let's take a look at that. Intrinsic. Find least significant. There we go. That's better. Let's go ahead and fix that. Find least significant. Okay. Thank you very much. That is definitely a typo. Yes, that's true. So Mosaico was talking about asserting the compression mode. It's true. We only load one type of compression now, which is compression mode 3. So while we are asserting the masks, we should probably also go ahead and assert that the header compression mode is still in that 3 mode, because we don't load any of the other compression modes at present. So we'd want to know if we got a file that didn't conform to that compression mode, so that we could be warned about it. It's a good point. So also someone was saying we don't need that intrinsic definition anymore. Well, we do actually need, so that's not actually true. So I'll tell you what the person's saying, and then I want to make sure that that is actually the case, because I'm not sure it is. So we'll talk about that. So basically what the person was saying, they were saying that you don't need this pragma intrinsic if you include intrin.h. But I'm not 100% certain if that's the case. Let's find out. So let's say we do that, right? Now let's go take a look at the code that gets generated, just so I can see if it actually still does that as intrinsic. It might, but I just want to make sure. because I don't actually know. Sometimes it doesn't. For other functions, I'm pretty sure it doesn't. But for this function, because they may not have done a separate implementation of it, then it might not. So that's definitely possible. All right, what am I looking for here? I'm looking for load bitmap, right? Load BMP. So basically in here, what we want to do is take a look at this and see what it generated. Go to assembly. Nope, so it does. Okay, so that's totally fine. So then it is fine without it. Sometimes the reason that sometimes if you don't put the parameter intrinsic, it'll only use it in optimized builds or whatever. And so I wanted to make sure it was. There's no reason for us not to always use it, but as long as it always does use it, then that's totally fine. Would it be worthwhile to avoid converting to float when doing the alpha blend? Well. So this is one of those things that basically what we'd have to say is, who knows? So technically, I think it probably would be in this particular case, right? But we're so far away from actually doing performance-oriented stuff that who knows? It may be that it really just doesn't matter for our purposes at all in this particular case. But for something this trivial, you can do it entirely without moving to float. But first of all, you'd never do this. You'd load the whole thing as a SIMD vector instead of doing the channels individually. Like, this is just not, we aren't thinking about performance right now. So thinking about whether you could convert to float or not is just not that relevant, because there's so many things that are wrong with this from a performance standpoint that it's just not really that useful to think about it. I mean, I actually would suspect probably that at the end of the day, we won't even be storing things in this format. We won't even have ARGBs. We might have like a buffer of A's, a buffer of R's, and a buffer of G's, and so on, right? Like, so things might. It's worth being aware of how your code is performing, but it's also worth knowing when you don't really care about some differences. And in that case, I think that's a difference we probably wouldn't care about that much. It might be interesting to do it just to show how you would do it without converting it to float. But yeah, do I expect this to be a major performance thing? No, not really, because we're already performing so poorly probably that I'm not sure how much worse this would really make it. It's hard to say. Why is the Windows logo still visible? I have no idea, because I don't know if you caught at the beginning of the stream, I was doing that tweak thing, that 7+ taskbar tweaker thing. And it's the thing that's causing the windows to not be on top. It might be possible that that's a thing that was intentional. So let me see if it's in the advanced options. I'm not sure. Let's see. Let's see why that's doing that. That's in the help over here. So let's see. Options EX. And 6 is about when the classic theme is used. Clicking on the screen corner, no. Customize horizontal paging. It does show the trick lock. Allows the customize show desktop button. So reverse the direction. Yeah, I don't actually know if there's a thing. I'll look for it later, but I don't see. Unfortunately, I don't see a way to get it to stop doing that. So I think that might just happen for a while until we figure out how to get rid of it. Let's see. Are there other ways to use are there other ways to alpha blend? And should you be taking into account which colors are easier to see, like green appears to be brighter than red? So, assuming that I understand your question correctly, I think what you're asking is, are there other ways to blend between two colors such that you're not just using per channel? So the first thing I will say is that, yes, there are many ways you could consider blending between two things. This is a linear blend, for starters. and it's linear in whatever space the colors are in, which themselves may not be linear. So we'll talk about this a lot when we get to the renderer, but basically what you have to understand is that the colors that are displayed out of the monitor are actually not linear. So basically, we think about these colors and we're doing this math. The math actually is assuming that colors are linear a lot of times, but actually the way things work is there's actually a curve. So basically, there's a color value that you set. So there's basically a value from 0 to 255 that we are setting, and we're calling that the color, right? So what happens, though, is that when that value is given over to the display, it actually goes through a number of mappings potentially. Once potentially on the graphics card and once potentially by the monitor, that actually changes the perceived brightness of that to not be linear. So then there's brightness here, right? And so what actually happens is there's some curve that happens here, right? There's some curve you can imagine where as you change the actual numerical value of the color, instead of it getting, if you change it from between 0 and 10, the difference in brightness may be much more than the same distance, right? 240 to 250 or something might be a lot less of a difference in brightness, right? Let's say, or vice versa, depending on how those curves are set. I think they're usually set in this way, but I can't quite remember. They're exponentiated, right? Yeah. Well, if they're exponentiated, they might be this way. I don't know. Let's take a look. So just to give you the, it's been this is the first graphics programming I've done in a long time, actually. So a lot of the stuff is rusty for me, to be honest with you. Let's see, sRGB gamma curve. Can we look at that? Can we get that up here somewhere? Gamma curve. Here we go. So linear space, and there's, well, that's not what I actually wanted. I wanted one on one side and one with the other. This is not giving me the values I want. I just want brightness on one side and value on the other. I'm not looking for gamma correction. I'm actually looking for just the... Doesn't anyone bake it down? I just want someone who's baked it down for me. That's really all I want. Well, let's take a look and see if this has it. So sRGB, that's actually got the full color cube. Here we go. sRGB intensities versus sRGB numerical values, right? So basically, let's see which one's red. So sRGB numerical values are red curve. These are the numerical values. And I assume that's the intensity. Showing exact. Below a compressed value is driven at linear intensity. Or at a linear intensity, this curve is linear, so the gamma is 1. Which curve are we talking about? All right, this is not what I wanted. I just want, why can't I get what I want? Maybe I'm misinterpreting these diagrams, but I literally just want what I just drew. I wanted something that's the value that you put into the buffer that's coming out, and how bright it appears on the monitor. That's all I wanted. I don't know why I can't get, I just want one graph that's just got that curve on it so that I can show you. But I don't know. Okay, so we can't get that curve. Maybe we'll look up that curve. I'll look up that curve outside the stream so I won't have to waste your time watching me try to read through documentation. But basically, point being, it's nonlinear. So it's entirely possible that that is a bad thing for your blend, right? You may be doing alpha blending, and you want this alpha was expecting it to be, let's say, a smooth linear transition, so as you change alpha, you get a smooth step all along the way. But instead, you're actually, if you're doing it in this exponentiated space, unbeknownst to you, a little bit of the blend actually goes a long way in terms of what the perceived blend towards the new color is, things like that. So there's alpha-corrected versions you can do of some of these things. There's other blend equations that do other operations that aren't designed to basically map one thing onto the other. There's pre-multiplied versus non-pre-multiplied alpha, which is basically getting rid of this 1.0 minus a term and baking it into gets rid of this a term and bakes it into the SR term, which is another thing altogether. So there is a lot of stuff that goes on here. I don't know if that's exactly what you were asking, but that's how that works. Whether you take into account the fact that channels work differently, I don't think so, because the images themselves have already had that taken into account, and you need to smoothly blend between them. So you could blend in a different color space, like you could blend, instead of blending in RGB, you could blend in HSV, or you could blend in log, or you could do other things like this. I don't know whether that's really such a good idea, though, because then what you'll get is you're not going to get smooth changes in the colors of the pixel elements on the screen, since they are RGB. So I think that's probably where you want to be for the operation that we're doing. But if you were trying to alpha blend, if you're trying to do an alpha blend that was trying to do something else, like smoothly blend hues of things together, then you might want to blend in a different color space, one that wasn't based on RGB, one that had different properties. I don't know. Sorry, I don't have a good answer to that question, really. I don't know. Yeah, I don't think I answered that very well, but there are different ways of blending things, but I don't know if they are exactly the way that maybe you're thinking about it. Are we at all concerned with the destination's alpha or blending with a transparent destination? Well, we are and we aren't. Basically, we're not concerned. The reason we're not concerned with the destination's alpha channel at the moment is A, because we don't. So 2 reasons. First of all, we never really write the destination's alpha channel because we don't care about it at all, right? So you can see in this expression, we don't even write it. It's always 0, right? The destination just always going to have a 0 alpha channel always. Now, that doesn't mean you have to do that. You can do rendering that uses the destination alpha channel to store important information that it will use. And this is basically something that we may explore later when we're actually doing our actual renderer, because there's reasons why you might want to use destination alpha to do things. But for right now, we don't have a destination alpha. However, what I do want to point out is this doesn't have anything to do with blending with other transparent things, because that actually just always works. Because basically, since we are always drawing things in Photoshop style, like I was saying before, where we're going to layer things down such that we start with the bottom layer, right, which has just whatever our base code is, right? It's some grass or something, right? And then we're going to like write onto that a tree or whatever, and then we're going to write on top of that the guy that's in front of the tree. Since we know we're always going to be doing that Photoshop on top of compositing, we will always work, because just like Photoshop layers always stack on top of each other properly, we will always stack on top of each other properly. If we were to draw out of order, right? So in other words, if we're trying to draw stuff stacked up, right? I'm going to try and do a really bad stacking diagram here. So if this is our background, and this is sprite 1, and this is sprite 2, if we're always drawing in this order, right, from the bottommost thing to the top, then stamping down, we know that all we're doing is writing in the colors of this thing where they exist and blending them with the background, whatever it was. So another transparent thing that comes on top doesn't have to care that the destination buffer is actually already the combination of 2 things. It doesn't care. It'll just stack on top of it properly. So it doesn't matter to this guy whether this guy had a transparent portion or not, because that's already been resolved by this guy, by this operation, right? By the time this guy writes to it, it's as if there only ever was one buffer, because all the things that came before it have already been slammed in there, right? If we were going out of order, if we were going to try and render the top thing, like this bottom thing, then this top thing, then the middle thing, and this has to insert between them, then that's the point where you start worrying about what was actually written into the buffer before, right? And that's all a huge mess. So basically what we want to do as much as possible, since we are a 2D game, we have the luxury of probably being able to always know the order in which we're drawing things, and that will let us do a bunch of things that are actually extremely difficult, in fact, sometimes impossible in 3D renderers. Which is basically order-independent transparency is what they have to do. And they have to do all kinds of work to make that stuff happen properly. It's really a nightmare for them. It's why games really hate stuff like looking through several sets of windows at some smoky particles, right? Having lots of translucence is actually really hard in renderers for a number of reasons. So they try to avoid those sorts of things, or do them with sort of what they'll usually do is they'll actually break apart the pieces of the scene that are transparent partially, and they actually will sort those. They'll draw everything that's not transparent first, and then they'll actually sort the transparent pieces and draw those in passes, just like we're going to do for our renderer. But we have the luxury of being able to sort all of our stuff, so everything will just work for free in that way. But they don't have the luxury of that because they have a much higher primitive count. They have a much higher primitive per pixel count than we do, and so they can't get away with that, right? So yeah. Will the final blend favor the source over the destination, or is linear good enough? I'm not sure what that means. We're really not favoring anybody. We're just using the alpha channel to tell us how much of the foreground should come in at that point, right? How much of the source should be used. So I'm not sure. Can you restate that question? Let's see. How would you deal with other picture formats such as PNG, JPEG, GIF, etc.? Well, we just write a loader for whatever the other format was. Or if you're lazy and don't want to write another loader, you could just run a conversion tool and then load them that way, right? You could just run some freely available conversion tool, batch conversion tool like ImageMagick, to batch convert your stuff from whatever your source format is into BMP. So you could either load them yourself or do that. Or, like I said, on Handmade Hero, we write everything from scratch, but you don't have to write everything from scratch. You know, there's no reason that if you can't use an image loading library if you'd like to, and there are several that are available. There's a thing called Free Image that loads images. You know, your mileage may vary, but there's libraries you can use, so it's entirely up to you. Yeah. Why is the mask so complicated to use? I assume the BMP format does that because it is somehow easier than doing something else. Why isn't the mask they specified something that can just be ANDed with the value or something? So I don't know why they chose that. It seems like a really bad idea to me. What I would have done is I would have specified the order, just hard-coded the order. And if I really wanted two different orders, like one for little endian, one for big endian, I would have had a flag. But you're right, the masks in BMP are complicated to use for no real reason. Like, why do we have to bit scan them? Because it was not a very smart format. Or store the shift in there too, right? Like store the shift in, like spend an extra 16 bits at the front of your file format, right? To tell what the shifts were. Something else that came up early in the stream, did you mean to call our alternative compiler LLVM or Clang? I always call it LLVM. Because really it's not Clang that really is the thing that determines what the intrinsics are. It's LLVM for the most part. Because LLVM either has those intrinsics in the bytecode or doesn't. And if LLVM doesn't have the intrinsics in the bytecode, then it's like Clang is just a thing that like spits out LLVM bytecode, right? Like, and so if LLVM bytecode has the intrinsic, then it has it, and if not, it doesn't. So I typically always think of it as LLVM, but you could call it Clang if you wanted to. It's up to you. In the bitscan function, what about returning the index and have it set to -1 if not found? I see search functions doing that a lot. Yes, you could do that. I find that to just be a little more error prone. So I would rather have there be a clear bool that you can switch on because the compiler is probably going to reorganize that stuff anyway, and so it just seems like an easier thing to do. Can you go over the linear alpha blend diagram again? Sure. I certainly can. So a linear blend is actually something that you can think about working between any two things, even if you don't really even know what they were, as long as they obey a few simple properties, right? You could almost think of it as just any 2 points in any space, right? As long as that space obeys some linearity things, which, you know, let's not get too crazy for the moment. But basically, if I have a point that I'm going to and a point that I'm starting from, right, and I want a linear blend between these, all I need to do to be able to do a linear blend is have a way of producing the sort of the difference between them, right? I need a way of being able to say A minus B. And I need to be able to produce that. And what that is, like A minus B, right? Sorry, B minus A, because we're going to B. So B minus A is basically telling me this motion. It's telling me how to go from A to B, right? So on a simple number line, right, if I'm talking about just 5, the number 5 is B, and the number 2 is A, I subtract them, right, and I get 3. It's the amount of steps it would take, the distance it would take to get from one to the other, right? But this works in all dimensions, not just one. So I'm just going to say, like, okay, it's something, it doesn't matter, 2 dimensions, 3 dimensions, 4 dimensions, I don't care. As long as we're talking about, basically Euclidean stuff here, as long as I can produce this, I can do a linear blend. And the way I do that linear blend is you can think about it exactly like you think about starting someplace and walking somewhere else, right? If I start at A, and I add in this difference, this movement right here, that B minus A, right? And I add in B minus A, I will get to B. That's just how it works. Like, you can think of it very simply. If I take the distance between these two things and I walk it, I'm going to end up at the other one, right? Now, technically, it's not quite a distance. It's actually a directional distance, right? I know what direction I'm walking to. And that's why it's important that we're talking about signed numbers here, right? B, if I say, like I said before, let's say B was actually 3 and A was the 5, or sorry, I guess 2 was what I said before. Let's say B was 2 and A was the 5. It's important that I don't end up with 3 here when I do this operation. I need to end up with negative 3 because it's a direction. I need to know which way I'm going, right? But basically, as long as you can produce that, you can end up with this, which is basically just, it's as simple as this. It's B equals A plus B minus A, right? This equation right here. If you can produce that equation for the things that you're talking about, linear blending is as simple as introducing this, right? You can produce that new point by saying, instead of walking the whole distance between A and B, I'm going to walk some portion of the distance between A and B, some fractional value. It can be whatever it is. It could be 50%, it could be 25%, whatever it is, and I will get however far along there I need to go. And that is a linear blend. Like I said, you can use algebra to rearrange it if you want to. You can multiply this out. If I have A plus T, B minus A equals some new value, I know that if I rearrange that, I can use the distributive property, T, B minus T, A, like that. And I can go ahead and regroup the terms, these two A terms. I have a 1 here in front of my A coefficient, right? And I have a minus T here. So that's just 1 minus T times A plus TB. I just regroup the terms. I group this term and this term into one term, and then the TB is still there. And that's the other form of the linear blend that you often see. So you've got those two different formats there, right? And so that's linear blending in a nutshell. It's very, very simple, extremely powerful. This one equation is so powerful, actually, that you will see it underlie almost everything we do in this game. There will be almost no part of the code that does not, at some point, compute some variation of this thing. So trust me on this one. You will have, if you don't quite understand it now, you will have a lot of opportunity to practice, because this is literally, this is probably, if I had to say, and I don't know, I haven't thought this through, I'm just saying this off the cuff, but if I had to say, this is probably the most important equation in all of gaming. Like, games need this equation probably more than any other equation. And there's tons of equations that are important to gaming, but if you could only have one, this is probably the one you would need, because games can't do anything without a linear blend, because everything else is built on top of it. Nonlinear blending is built on top of it. All of rasterization is built on top of it. All of animation is built on top of it. It's just incredibly, incredibly important. I'm unexperienced with Windows. I know we do a large virtual alloc at the beginning. Is this basically the same as mmap in Linux? Yes, for the most part. I'm not super experienced with mmap, so I'm not prepared to say exactly, but what I would say is I would encourage you, if you have questions like that, the best place to go at the moment, since I haven't really looked at the Linux stuff and haven't done an implementation of it yet, if you go to handmadehero.org, click on News and Forums, there's a coding resources page. If you go to that coding resources page, go to the Linux listing and click on handmade Penguin SDL port, because I believe, and I'm sorry if it turns out to be wrong, but I believe he actually explains how to do all of the stuff that I did in Linux. So you can kind of go through here and look. So there's that mmap, and it appears to be in the same place as our virtual alloc. So take a look at that page, Handmade Penguin, because that would probably be the best place to go for an explanation, since I know he's actually worked it all out already. Let's take a look here. What bit value is 50% brightness? Well, it'd be, you have 0 and you have 255, so you can either think of it as 127. Well, okay, so here's how to think about it in our actual thing, right? Here's how to answer that question, basically. So you know that the alpha value that we're pulling out is going to be whatever the alpha value in the bitmap is divided by 255, right? So if you think about it, what we would want to do is say, all right, if we have 128 divided by 255, what is that? Well, it's 0.50 something something something, right? Not quite exactly 50. 127 divided by 255 is 0.498 something 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 something, right? So the actual answer is that there is no actual value for exactly 50. 127 is a little bit low, 128 is a little bit high. What are you going to do? You could adjust this math to make it exact, you know, if you wanted to, right? But the problem is you want to make sure that 1 is exact. So you need to make sure that 255 by 255 is 0. Like, if we were to do 128 divided by 256, you could get an exact. So if we divided by 256 here, you could get an exact, but you could never get 1. Because then your highest value is 255. You would end up never quite being able to get 1 either. And that has consequences as well. Worse consequences, in fact. Let's see here. Let's see. What else we got? Does the display blit operation actually do anything with the alpha channel? No, it just writes 0 to the alpha channel. It's only using the alpha channel as a control, to basically control how the blit operates. So it's reading it, but it never writes it, if that's what you're asking. Which I think is what you're asking, but I don't know. The solid curve on Wikipedia's gamma correction is the linear space intensity, should be what you are looking for. Okay, so you're saying go to Wikipedia and look up gamma correction, did you say? Or something else? I'm sorry, I just spaced out there. Let's see. Oh, we're out of time. Let's just grab it at the end. Solid curve on gamma correction. Okay, so gamma correction, Wikipedia. So you're saying there's a solid curve on here. Okay. So you're saying this curve right here, hopefully is what you're saying. So I didn't do the reading yet, but assuming that that's a solid curve, basically, is this, what are the two axes though? The dotted line indicates the linear transfer function, solid line shows CRT. What are the axes, by the way? Which axis is which? Hi there, guys. Can you tell me what the axes are? Because which one is the brightness and which one is the input value? Example of CRT gamma correction. The dotted line indicates a linear transfer function. The solid line shows how a typical CRT behaves. The dashed line represents the inverse function. So I guess I don't actually know. It doesn't say. I assume this is brightness and this is the input value, but I guess I don't actually know. Assuming it was, then you can see that's what the curve looks like. So it actually has a lot more kind of resolution there at the bottom than at the top. There's not a lot of resolution in the brightness, but I don't know. I don't know if that's reading this right because it doesn't actually have the thing. So we'll have to look at that in a little more detail later. All right. Let's see. I think that's about it for stuff we can cover today. We have gotten, this is pretty good. We have gotten to the point where we can now do layered graphics on the screen. So I'm thinking it's it's kind of a question to some degree about where we go next. Like, what is the next thing that we should be doing if we're actually talking about moving forwards on the game. And so what I was thinking of doing next is working on our player motion code, because I think that's important, because it's going to basically speak to how we need to do our collision detection, which speaks to how we need to interpret the tile map. So I was thinking of doing is basically saying, all right, maybe we do a little cleanup tomorrow and Friday of stuff that still needs to kind of get cleaned up a little bit, just looking at things like that, see what we want to do in terms of that sort of stuff. But maybe what I was thinking is, so we'll start next week on like actually talking about linear algebra and vectors, and we'll actually start writing the movement code for the guy for real so that it feels good, and we'll start talking about collision detection for real so that we can kind of see what we need from our engine for that, because that's a really big important thing to spec. That's one direction to go. The other direction to go is we need to talk about how to actually build these background bitmaps, right? Which is to say, take the tile map and kind of go ahead and build the background bitmaps. I don't know which one we should do next. It's kind of a tough thing to say. So it's a toss-up. Maybe we'll flip a coin. Maybe we'll take a poll. I'm not sure. Both of them have to get done before we know what our engine spec really truly is. So it's something to think about. But for now, we can at least be happy that we now have a nice splitting engine we can use, so we can put stuff up on the screen, which is kind of nice. And from now on, we'll always have graphics to back us up, which is much nicer than looking at a bunch of rectangles, in my opinion. So thank you, everyone, for joining me for another episode of Handmade Hero. It has been a pleasure coding with you, as always, and it was a pleasure talking about the linear blend, which, like I said, is one of the most important things. You will see it come up again and again and again on the stream. So it was nice to finally get to that. I think that's a pretty big milestone, starting to actually use the linear blend. And again, like I said, we'll talk about it a lot more in the future, and we'll see a lot more about it, and we'll kind of learn more and more about how interesting it is and how intricate you can, basically how amazing it is that you can do so much with such a simple function, and basically how it underlies everything, if you will. So anyway, thank you very much for joining me. If you would like to follow along at home with the source code, you can pre-order the game, and it comes with full source code already. Every night I update the source code, and you'll basically get a link in your email that you can use to download the source code. It also has the art assets that we've been using on the stream. There's a separate zip file you can download if you want to use, like the little guy and the backgrounds and that sort of stuff for doing your development. And so anything, you can basically completely follow along at home, and all the assets that you need to follow along completely at home come with that pre-order. So check that out if you're interested. We also have a Patreon if you want to support the video series. You can always subscribe there. We also have that news and forum site, which I showed just a few minutes ago, which has a ton of resources for people who are trying to learn on the stream. It's got a lot of great stuff. The schedule for the week is always posted here. There's also the episode guide, which allows you to catch up with old episodes. Got nice annotated video series on there. Coding Resources has the ports, like I showed before, and other resources you might need, like good documentation stuff. And there's a forum you can post in when you need to ask questions. So please check that out. If you're trying to learn from the series, it's a great resource, and there's a lot of very helpful people on there who are very nice on the forums who will also try to answer your questions if I'm not around to do so. So thank you very much for joining me. I will see you tomorrow, same time, same place, 8 p.m. Pacific Standard Time on Twitch. So I hope to see you all there, and if I don't, have an excellent Thursday. See you later, everybody.